Good afternoon, and no, I did not lick the pencil. We're going to talk about Abacus, new accounting software we're developing at the Dutch Electoral Council. And I'd like to start with what this presentation will contain. So first we'll talk about what is the Dutch Electoral Council and what do we do, how the voting process works, really important. Then we'll introduce what Abacus is, what are our goals, what functionality will be in there and how will we improve the usability of it, what technical choices did we make, what does the architecture look like, and then how we work as a team and how we develop open source. And next we'll go over all the security measures taken during an election and then also in Abacus. And after that there's room for questions. So who are we? And take it away, Ellen.
So I am Ellen van Leeuwen. I'm a software developer, full stack. I worked at Secura actually for 5.5 years. And then I started at the Kiesraad at the end of April this year. And having a great time.
And I'm Marjolein. I'm a documentation specialist. I work at the Kiesraad. I've worked there for about a year now. And before that I worked on a project some of you might know as Corona Check. And we're part of a team here with 12 people by now. Some of you are in the room, so welcome. And our CISO is Fleur. She's right there. So, okay. So let's go on with what does the Electoral Council do? The Council is an independent entity. It has 7 members. The Bureau of the Council consists of 40 plus employees and counting. We've been expanding quite a bit. We have different teams. There's a legal team that oversees the quality of the electoral process, and our team, data and technology, and our CISO. And then let's go with the tasks of the Bureau. So first of all, we determine election results, obviously. We act as a central polling station in national elections. And there's also the part where we provide advice and support. We advise government and parliament about the electoral process and electoral law. And we do this when asked, but also when we see a need ourselves, or when we get input from stakeholders or people who just have good ideas. On the support side, we provide support to all the stakeholders, which is municipalities, gemeentes, political parties, and people who work anywhere in the voting process. We also provide the necessary tools, and on the one hand, that's the models and processes, the models that are used for the tallying of the votes, which we call a proces verbaal. And processes that are used everywhere in the election process. And, well, then there's the technology and software, including the website, software for accounting votes, that's us, and calculating the seats. We have defined several principles that are required to have trustworthy elections. You might have seen these already yesterday with Fleur's talk. I'll go over them a little, just very shortly. There's independence, where the Electoral Council is part of the Ministry of Internal Affairs, but it's largely independent with its own budget and responsibilities. There's transparency. Everyone should be able to see how the voting process works. Freedom to vote. You should be able to vote on the candidate of your own choice. Voting secrecy. You should be able to keep your voice to yourself if you want to. If you don't want to, you can tell everyone, of course. Accessibility. Everyone should be physically able to vote, and also it shouldn't be too difficult to vote. So, it should be an understandable process, which is, if it becomes too difficult on the actual ballot, that is a problem. Integrity, making sure that the elections are honest and fair. Verifiability, being able to check the results for yourself. The right to vote. If you're entitled to vote, you should be able to. And unicity, everyone can only cast one vote. And of course, we are going to focus on the 3 green indicated ones. Integrity, transparency, and verifiability. They're most important for our software. An overview of elections. We have different election types, and all of them have slightly different processes. We want to have a working version of Abacus for the municipal elections in 2026. And ultimately the goal is to incorporate the processes for all election types into the software. The examples given in this presentation, though, are for a House of Representatives election, Tweede Kamer. Next. An overview. So in a Tweede Kamerverkiezing, House of Representatives elections, there are 10 million voters. 100,000 volunteers help out during the entire process. There's 10,000 polling stations throughout the country, and all 342 municipal polling stations have there are 342. I thought there was more, there wasn't. There's 20 electoral districts and 20 district polling stations. We are in the electoral district of Haarlem, so that means that Haarlem itself and also a bunch of other municipalities in the area are in this district. And there's one central polling station, and as the kiesraad, that's us. Then casting and counting votes. Well, you all know that. You vote on paper ballots. In the polling stations, there are strict rules for to make sure that voting secrecy is preserved. And volunteers do a course so they know how to follow those rules and they can apply them. After that, the votes are counted by hand. Most municipalities have a system for this. And in all cases, they maintain a 4-eye principle, which means that 2 people count all the votes. Then this is what a report looks like. It's not very, maybe it's not very visible yet, but it's also a small part of the real thing. The chair of each polling station fills this out when the voting and when the counting is done. All that paperwork then goes to the municipality, which is usually a town hall, or it could be a different location specifically designated for elections. This is an interesting one. I might use a laser pointer for this. So that's what I just described. That's the paper part. So the votes are aggregated and counted. That leads to a polling station report. It happens on paper only. And after that, the results are processed at the municipal polling station, where it's entered into the software by a data typist. Any errors and any problems will get checked and verified. And if there are errors that really need solving, then that's going to be done first. If everything's okay, it leads to a municipal polling station report and an EML file. And EML is something I have to explain. EML stands for Election Markup Language, and EML-NL is a specific format of that language, and it has been adjusted for Dutch elections. So that process repeats itself on the district polling station level and the central polling station level. So in a district, the municipal report gets entered into the software there, and that gets a district polling station report, and the district polling station reports get entered into the software at the central polling station, and that leads to the eventual report for the central polling station. And that's what we use to calculate the seats. So the middle part of that was software, and that's where Abacus comes in. So first of all, I'm going to talk about the goals. And I thought I'd add a cat picture because we do cats. I like that. Abacus will be designed to provide digital election results to prevent counting and writing errors, which is something that always happens, of course, wherever people work. Our design and implementation need to follow those principles you just saw, integrity, verifiability, and transparency being the biggest ones here. The interface and technology should be easy to use. That's what Ellen's going to talk about soon. After that, the software should be fully open source, as is dictated in our electoral law. The current software we have doesn't completely comply with that. We do publish reports for that, but that's not entirely correct. So that's what we're going to do, open source. And the Kiesraad wants to take ownership of the software development process and the knowledge required, and developing the solution in-house fits in that bigger picture of ownership. So now I'm going to give it over to Ellen. She's going to tell you about what it looks like and what the architecture is like.
So we started developing this new software this year, basically half a year ago, basically. And this is so far what our one of our data entry pages looks like. And as you can see, there is a nice, navigation style section on the side. And that's where this part of our improved usability, where that comes in. So let's start with regular user testing with real users, because there's a lot of software projects that sort of start doing this at the end when they finish building it, and then it turns out it's not at all what it's supposed to do. It doesn't do what the users actually need and want. So actually last Friday we did our first real user test in a lab and everything with 6 volunteers, and we already got a nice list of points that we can improve from that. So we really want to prevent users from being harmed using Abacus. So that's where the meme comes in. One of the big things is that we don't want a very long one-page form. But we want separate sections, and every section needs to be checked once you submit it. So you don't have to solve a whole shitload of errors at the end, but you can just solve stuff as you go, check it as you go. We also want to add the ability to pause and save the form to continue later, because sometimes you might have to go to the toilet, or maybe the fire alarm goes off, and you should be able to pause the process and leave your computer. And come back and continue instead of everything being thrown away. The software also needs to be optimized for keyboard usage and learnability. So what we found is that especially inputting numbers is way easier if you only use a keyboard and not have to keep switching from mouse to keyboard. So we want to make it as accessible as possible and usable as possible by basically navigating the whole thing with a keyboard, at least most of it. And it will adhere to all the accessibility guidelines, because, we're a government organization, so we actually have to, according to the law. And our software should offer clear guidelines, guidance on how to solve incorrect or inconsistent input. So there should be very clear messages on what does the person that does the data entry have to do to fix this warning or fix this error. That just makes the usability way better. So this is a concept overview of the functionality, very nicely created by our team lead. So again, it is still in development, so this might change, but at the moment, this is how it will work at the municipal level. So on the top, you will see the import section. So all the candidate lists and election files can be imported through email. So you don't have to manually, add all 500 polling stations in your municipality and stuff like that. This can all be done via imports. Then on the left, there's the data entry section. So all the certified election results that come from the polling stations are going to be inputted into the software. And this includes all the counts, but also statements that happen there, complaints or other things that have been noticed at the polling station. Those can all be recorded into Abacus. And data analysis will be done in this step to also add warning messages for small deviations and error messages for larger deviations and inconsistencies. So there's a whole audit protocol that will be added already in this software, instead of doing it all the way at the end, and then you have to send it back to the municipality again to have recounts done and everything. So then on the right-hand side, you have the signature section. So we want to be sure where this data came from. Is it actually entered by the municipal polling station? Did someone actually sign off on this? So we want to be sure that the chairperson of the municipal polling station can sign off on the entry. And we are still working on a solution how to do this in both a user-friendly and a trustworthy way. And then on the bottom, there is the export section, because of course you can input data, but you should also be able to, make nice information out of it. So there's both a results export in the EML standard that we've talked about before and in the PDF standard. And those will then go to the district polling station and continue later on to the central polling station. So most of this is repeated. And at the central polling station, there is also a seat allocation section that will be added. Because of course you want to be able to, say which candidates actually ended up in the, the body that they are on the ballot for. So let's talk about some technical choices that we've made. If we're talking software here, so, there's a lot of things that go into deciding what languages to use, what frameworks, etc. We want to make it as accessible as possible. A lot of, municipalities do an election once a year. They don't have the fanciest laptops or computers for this. So we want to make it accessible through a web browser, which means that we're going to use HTML, CSS, and JavaScript. And we decided we were going to use TypeScript for a more extensive version of JavaScript with mandatory typing, because this really reduces the likelihood of mistakes and makes, in general, developers write better code. And then for the interface, we use React. So of course, quite popular, well-known, and well-maintained library, which is very important to us. For development and testing of components, we use Ladle, which is a bit of a simpler alternative to Storybook, because we want, of course, be able to model our components before, putting them on the page. And our front-end unit testing is written with React Testing Library and VTest. And we use Playwright as our browser test framework, because, of course, we want this to work on, I think, 4 browsers we've decided. So it needs to work on Edge, Safari, Firefox, and Chrome. And then for the backend, we had quite a few requirements for the programming language. So we wanted a higher level language to increase the programming efficiency and not having to worry about doing specific memory allocation like with C, for example. We also need a strict type system to, again, reduce the likelihood of bugs. And the language needs to be open source and preferably maintained by a community instead of a single party, because they might end up taking it closed source or offline or who knows. It might become orphaned somewhere. And of course, there needs to be available programmers that are willing and able to, code in this language. And considering these requirements and weighing the pros and cons, we ended up choosing Rust as the backend language. And a specific pro for Rust was that it's used in many security environments and also has a really security-aware community, which really helps in trying to make very secure software. Besides that, we also aim to minimize the number of dependencies we use, so we don't have to trust as many third parties. So a lot of, we don't use that many plugins and things like that. We try to, if it's feasible to do it ourselves, we will do it ourselves. And of course, we're not talking about cryptography, by the way. Never do that yourself. Then the database, we use SQL, and specifically SQLite. It's a very popular, lightweight, easy-to-use library, and it requires no installation, making it easier than PostgreSQL, which you really have to install on every computer or package with the installer. And this was just, a way easier solution. Then let's talk a little bit about the architecture, and basically in the same time the process as well. So it's a bit of a mix. It's very simple. Like, we want to make it as simple as possible. You don't have to make things complicated. So basically we're going to have 3 different roles. First of all, the administrator, they will be able to administrate and manage elections and users. Then we'll have the coordinator, which can coordinate the session and the data entry session, and the election session and the data entry process. And then we have a lot of typists that are going to do the data entry. So that means taking a report, adding all the numbers into the software, and solving issues as they might come about. And all these users will interact with the TypeScript React frontend via the web browser, and the frontend will communicate via a JSON REST API with the backend, and our backend will read and write data from our database, as standard system. Then let's dive a bit more into the backend, because basically we try to model the whole election process or the election result process in the backend. So first of all, let's start on the left-hand side. We'll have the component for users, which will manage the administration, authentication, authorization of the users. Then, of course, we needed the administration component to make the elections, election data, and the session, to administer all that. The election data contains political groupings, candidate lists, and polling stations. And those can all be imported through EML. So we need a nice way of converting that into our database as well. Then, of course, we have the data entry section. So that's where the core business is, basically. The entry and the validation of the vote counts. And once that has been done twice, so the data entry for each report is done twice to, again, prevent mistakes and differences from occurring, it will turn into a counting result. And those are the fully validated and checked polling station results, counting results. And basically, once this whole process has been done and we end up at the central polling station, they will also then do the seat allocation. So based on the counting results, we can decide which candidate gets what seat. And then, of course, we had to export. So we will export the results on each level, both in EML, NL format and PDF. And of course, we also need some statistics. We want to show how everything went. So for the whole result determination process, we'll have some nice statistics and also publish those on the Kiesraad website, probably. So how do we work as our team? It is quite rare that, the government does in-house software development. So, it's very nice, a very cool opportunity. And again, like I said, we work fully open source. And that means including the pull request. So really our whole process is open source, not just the code, but actually our whole process. So issues, pull requests, everything. And we have a public GitHub repo. More on that later. We have, of course, a full CI/CD pipeline. We have, with all kinds of, front-end and back-end testing, linting, and every PR and the main branch also include a link to a preview GitHub Pages website where all the new functionality can be viewed and tested, which is very easy also for outsiders, let's say, to check what we're doing. Of course, every pull request needs 2 mandatory reviews and approvals. And of course, in a lot of cases, we maybe get 4 reviews because we have different expertise in our team. We have some front-end experts, we have back-end experts, we have design experts. So it's nice if multiple people with different expertise look at the new functionality. We, of course, always test our new code. So we don't just make an issue for, we're going to write tests for this later and it ends up on the backlog. No. You have to write the tests for the new functionality in that same PR. And of course, like I said, we use Playwright, React Testing Library for that, and Cargo for the backend testing. And we also have a fully public UI UX design, which is, I think, very exciting. It's very nice. We have some very skilled designers working on this. And you can also make feedback and leave comments on that, actually. If you think something is not clear, we're very happy with all the feedback we can get. And this is also linked on our public repo. Let's go to the security measures, of course, what we're all here about.
Thank you. So security. Let's start with the first one, which is the 4I principle. Well, counting, we've already talked about that. There's always two people counting all the votes, and that speaks for itself. All the officials sign the official report from each polling station. So that means there's a full paper trail. Everything is saved and everything is kept, and the paper trail functions as a single source of truth. When there is any doubt, the paper trail is the one we adhere to. There's physical security present at the polling stations in the form of locks on the ballot boxes. There's guards. When all the ballot boxes go to the municipality, they're guarded behind lock and key. And at the central polling station, where we perform the last step of that process you just saw, we have guards there 24/7. Of course, just like security anywhere else, the people involved are somewhat of an unknown factor. They may make mistakes, and if we put on a black hat, some might even have malicious intent. We haven't really seen that thus far. However, there are many checks and balances in the systems. We've gone through many of them already, so we will always double check if there are any suspicious errors or deviations. Then there's the data entry part of it. We also enter the data twice, so there's also a 4I principle there. Each report is entered into the software by two different users. We are working on sender verification. That's actively being worked on by my colleagues over there. We are working on the precise method, but we're exploring possibilities around key signing and implementing extra safeguards. Any input on that is also very welcome. Then there's the audit protocol, which happens at all municipal polling stations, which is where each municipality picks 3 random lists. So it might be, for instance, lists 2, 8, and 11. This is an extra check to make sure that the digital count and the paper count is correct. So they recount those 3 lists and they do that extra check. It's just a sample, of course, because if you were to recheck all the lists, that would be a lot of work, and we don't want to make them too busy. The solution will be air-gapped and locally run. Which is also, that is the best way to do it. If you were to hang that computer on the internet, it's like, that's not gonna work. There's a lot of security issues there, and especially with a smaller dev team, we do not have the capacity to mitigate all the security risks there. And all the data is published before the elections are certified. So, municipalities publish the results on their websites. So each municipality has one of those reports, and they put those and all the polling station reports on their sites, so you can check your own vote if you want to. And we also publish the central polling station data on our site, www.kiesraad.nl. Then it's time for security in Abacus. I'm going to give it to you again.
Yes. So, of course, we had to put the count on one of the slides. And yeah, security in Abacus is, of course, not an afterthought, but a requirement from the start. So, of course, we will have internal and external code reviews. Like I said, it is also built into our whole approval process of pull requests. But there will also be external people coming in and reviewing our code. And of course, it's open, so everyone can do this and can comment on it. And our first external code review is actually coming soon. So even if when we're still pretty early in the process, we are already having people come in and review our code. Of course, we'll have external pen testing done. We don't have internal people for this, and we will have different. Next year there will be pen tests going on before it officially gets, signed off to be used in the elections. And at every step, of course, we check if the software still adheres to our legal requirements. Like I said, one of them is open source. Well, that one is, ticked off, but there's more legal requirements for the software in the law. And community feedback is, of course, very valuable to us. We don't work open source for no reason. So we both have a binary build that can be downloaded, and you can run it on your own machine and see, what we're doing so far. And like I said already before, there is a GitHub Pages deployment for every pull request and the main branch. And this does have a mock backend, not the Rust backend. So this is a bit more limited in the actual functionality. So it's better to just run it on your own machine. And that was basically our presentation. If you have any questions, let us know. Visit this link or scan the QR code if you dare. No, it's not a Rickroll. It's actually the link. We need you if you want to comment on our software.
We need you.
You're very welcome. And we hope you want to check it out.
I have to do the walk myself. So are there any questions? Oh, that's close by. Thank you very much.
Yes, actually, I've got a bunch of questions. I've got some experience with OSV 2020 from GR 2022. And I've seen one of the slides. There's a nice image of a flash drive. Obviously, in 2020 with the 2020 software, I noticed that locally they had a NUC at the town hall, which was standalone. But I'm coming there with my flash drive, which has been plugged into the NUC. Right. Hey, Stuxnet? All that sort of things to begin with.
Yeah, we actually discussed removing the flash drive from that image, which is really funny now that you say it. We are looking at other ways of doing that because that's obviously a security risk in itself. Maybe not the biggest one, but it's certainly up there. Yes. So.
Second question, is OSV going to be replaced by Abacus completely? Also for the party side to enter into the elections?
Do you want to answer that one?
It's not going to be fully replaced yet. So the whole candidate part, that is still going to be used. I think they're also making a replacement for that, but we're not at the moment doing that. So that will be a whole separate project. So OSV will still be used. By the way, that's the current software that's being used. But the whole part for the data entry, that will be fully Abacus. So,
Okay. Yeah, because to be honest, my experience with OSV 2020, and I've actually called it software.
We're aware.
There is a reason why we're doing this, yes.
Because there's a lot of things that go wrong. First of all, installing it already goes wrong. Because you couldn't install it if you had the source on drive D, you couldn't install it because it could only be installed from drive C on drive C in Windows.
I do want to defend them though, because OSV was created in a record amount of time by a company which already had a German election solution out there, and they adjusted it for our elections. And there's obviously a lot of problems doing that. They have a different system than we do. I think the work that they did on that was impressive, really impressive, except it's still never going to really fit our elections. That's just impossible with what they have. And that's why we want to replace it. But they absolutely did an admirable job there. So.
Well, I'm very curious to the next one. Next time, I guess I'll be there again from the party side to doing it.
Okay.
But I also, one of the things, you installed it and you need to open it from the browser. Mm-hmm. And the first thing the browser says, hey, this is not secure. Because it's got high HTTPS to access it. And it's a local drive. Okay.
That's true.
I'll stop here.
You're right.
Enthusiasm is good. Enthusiasm is good. Other questions? Oh, yes. Ooh. It's a long day.
Don't fall.
Yes, I have a question about the web browser that's used to enter the election results into the central service. How's the DNS resolved, and how does the user know there is no man in the middle between their web browser and your server?
Good question. I don't know how to answer that, to be honest. I'm not the architect. That's my colleague. So we're definitely taking all these things into account. So we'll make sure that we have ways to know if something has been tampered with. But it will run in a local network, so it will hopefully not be connected to the internet, and will already be a lot more difficult to have a man in the middle if you're not connected to the internet. So it's not fully out of the way, of course, but yeah.
I can actually maybe...
Oh, yeah. Oh, yes, please, Fleur.
Please do.
So if there were a man in the middle, there would actually physically have to be a man in the middle, because it's a local area network. So it's a server, a switch, and a couple of clients. And that's it. So if you want to be in the middle of that, there's no internet, there's no network other than what you can see. Like I said, it would have to be physically a person in the room that is doing this.
Inside a threat. Sorry, won't break it up. Won't break that open. Other questions? No questions? Yes. You thought, oh, she had to walk. That poor woman. Well, that poor woman chose herself to wear the heels, so.
Sorry. Hi. So this is all local. How do you stop the security threat from when you export the EML and then shift it onto the next part of the process?
Good question. Let me again. Maybe Fleur can actually talk a bit more about that. There's a lot of animations. Oh, all the way back more? Yes. Wait. Yes. There we are.
Yeah.
Yeah.
Yes.
We're going to do this. People give the mic to Fleur. Here. No? Here, give it to her. Yeah.
It's a very simple answer. It's the signature and the sender verification. That's so we are actually currently still working on it. We have a couple of designs for it, but you are free to give us feedback and help out. But we are so currently in OSV there's a signature and a hash, and that's how we verify that in transit the file has not been modified. As well, there's a paper trail that's going alongside. And we do checks, like my colleagues explained, the audit protocol, where we check 3 parties, the paper trail versus what comes out in the EML.
Moet je microfoon even terugbrengen? Ik loop wel.
Thank you so much for this talk. And then let's see, in a couple of years, maybe you can talk about what happened and if it worked, right? Yeah. Thank you so much.
We'll be back. Thank you.